and comparator. So these are the basic gates which can be used in any digital system or design. Now let's see what are the ICs which you can use in your lab session for different practicals uh, to form different digital design circuits. Various ICs are available, and the series will start with the 74. So these are the IC numbers here. 7400, it is a quad 2 input NAND gate. 02 is 2 input NOR gate. But here you can see whatever green color I have shown in this chart, that is 7400, 7404, 08, 20, 32 and 86. So these are the basic gates which you are going to use in your lab session for basic electronics practicals, or also for a DELT subject in your second year SEM 1. So these green colored ICs are the basic gate ICs. Now let's take one example to understand what is inside this ICs, or how the gates can be used as far as your practicals are concerned. So let's see. We'll take the AND gate here now. So quad 2 input AND gate. So quad means there are 4 AND gates available in this IC 7408, which is having 2 inputs. So let's see the pin chart of this IC. So this is the 7408, which is what AND gate IC. So here you can see this is the IC which is having 14 pins, and it is called 14 pin DIP IC. DIP is dual inline package. That means half pins is at the left hand side, half pins at the right hand side. So now in this IC, 7th pin is ground pin and 14th pin is VCC pin. Except these two pins, all other pins are assigned as input or output. So let's start with the first gate. So now this is the first gate, for example, first, second, third and fourth. So now for first gate, pin number 1 and 2 is input pins, are the input pins, and pin number 3 is output pin. Similarly for second AND gate, 4 and 5 is input pin, 6 is output pin. For third AND gate, 8 is output pin and 9 and 10 are input pins. And for last, that is fourth gate, 11 is output pin, 12 and 13 are input pins. So this is how inside or the internal view of this IC. So now if you want to use the 4 AND gates at the same time in single design, so you have to use these particular pins as an input and output pins here. So you have to follow this IC chart. Now let's take one more example, NOT gate. So here you can see what is IC number for NOT gate. It's a 7404, or hex inverter NOT gate. Hex inverter. Why hex is called? Because in this IC there are total 6 NOT gates available, because it is having only one input and one output. So 7404. Let's see, 7404. I think this one only. Yeah. So here you can see 1A is input, 1Y is output. So this is your first NOT gate here. For this one, pin number 1 is input, pin number 2 is output. So first NOT gate, second NOT gate, which is having pin number 3 is input, pin number 4 is output, and third NOT gate. And again, as like a previous or other all of the gates ICs, 7th pin is ground pin and 14th pin is VCC pin. So 3 NOT gates is at the left hand side, 3 NOT gates at the right hand side. So total in this IC 7404 there are 6 NOT gates you can use in single design. If you want to, let's say you are going to use 8 NOT gate, then you have to use the second 7404 IC. This will be your first IC in which you are using 6 NOT gates, and from second 7404 IC you are going to use 2 NOT gate. So this is how practically you can use this ICs. Now Let's see the next point, or the last point in this today's lecture, is your timing diagrams, or also it called as a voltage waveforms. So let's see the first AND gate. So we know this symbol. These are the inputs and outputs. So A and B is input and AB Y is equal to output, which is nothing but A dot B. Now I've drawn one where timing diagram for AND gate. Let's just look and look at that diagram and I'll explain it here only. I've drawn it in paint. Okay, so for each and every input and output, there will be a two logic levels, because this is a digital signal which works on two different logic levels. Logic level 0, that means logic level 0, and logic level 1. So in our AND gate, there are two inputs. You can see symbol as well as truth table. A and B are the input, A and B are the input, and Y is your output. So now in this diagram, you can see A, input B, and output Y. So let's see how to draw the timing diagrams for any gate here. So first draw the dotted lines for two logic levels 1 and 0 for all the signals, for all the inputs and outputs. So I drawn for two logic levels for input A, input B, and output Y. So now let's start with the first combination as per your truth table. So it is what? Both inputs are 0, 0 here. So output is 0. Now how to draw here? So input A is, let's say, 0. This is my 0 level. Input A is 0. Input B is also 0. That time output is also 0. So this is my first input combination. Now second truth table combination is 0, 1. Output is 0. So 0, input A is 0. Input B is 1. That time also output is 0. So this is my second possible input combination. Similarly, third, input A is 1, input B is 0. So that time output is also 0, because this is a multiplication AND gate. So 0 into 0, 0, 0 into 1, 0, 1 into 0, 0. And now only one combination is remaining in your truth table, that is both inputs are 1. That means output is also 1. So last combination, input A is 1, input B is 1. That time output is 1. So at this instant, that means fourth instant, this will make output Y will make the transition, because all other inputs output is 0. So it will remain in a 0 state till your last possible input combinations. So at this instant, this will make the transition from 0 to 1, and it will remain in a 1 till your inputs, both inputs are 1. So this is the timing diagram or voltage waveform for AND gate. Okay, now we'll take one more example, that I'll draw the timing diagram in paint for your better understanding. So I'll create a one paint file again. I'll open the paint file. Already I have drawn the logic levels 0 and 1 for input A, input B, and output Y. Now let's start with we'll apply this input to the OR gate. So here is the OR gate. This symbol, this is truth table. So as per truth table, you have to apply inputs. So for first input combination, A is 0, B is 0, output is also 0. Now how to draw here? So I'll take, let's say, I'll take green color shade, increase the thickness also. Okay, so now input is 0. So this is the 0 level for A. Input is 0. Input B is also 0. Input B is also 0. So that time my output is also 0 here, first one. So now output is also 0. This is my first possible input combinations as per my truth table. Now second, 0, 1, output is 1. So 0 plus 1 output is 1. So input is again, shall I use any other color? Yes, I can use it here. So now for next possible input combination, input A is 0, input B is 1. Now here it will make the transition and it will remain in a 1 till this point. So this is 0, this input is 1. So this is the OR gate operation. So 0 plus 1 is nothing but output is 1. So here it will make the transition in output. It will remain in a 1. And for first input combination, here input A is 0, input B is 0, and output is also 0. So this is the second possible input combination. And third is again input A is 1, input B is 0, output is 1. So again I'll use any other color. Yes, blue I can use. So input A is 1 now, so it will make the transition from 0 to 1. Output A is input B is 0 now, it will make again transition, will come back to the 0 level. So this is 1, this is 0. That time output is 1. So 1 plus 0 is 1. So it will remain in a 1 same state, that is 1. Okay. Now this is third possible input combination. And now last possible input combination is what? Both inputs are 1, output is also 1. So again I'll use any other color. Okay, I'll use this one. So now both inputs are 1, both inputs are 1. So here it will make the transition from 0 to 1, and that time output is also 1, output is also 1. So this is how to draw the timing diagram or voltage waveform for any gate operation as per the truth table. So for 0 0 input, output is 0. For 0 1 input, output is 1. For 1 0 input, output is 1. And for 1 1 input, output is 1. Now based on these three points which we have studied till this point, so just note down this assignments. I have given some assignments for this today's lecture. I hope you will solve it and put it on your classroom platform there, Google Classroom platforms. So note down these 4 assignments. So whatever required notes or the material is here for today's video lecture, I have uploaded in this same uh, lecture in Google Classroom. Just log in and you can check there. Thank you.